Let's talk about the chain rule. What I really want to talk about is the chain rule for vector functions, but this is the chain rule for functions on one variable, just like we would have seen in Calc 1. Let u equal g of t be a differentiable function at t, and let f be a differentiable function at u. Then, the derivative with respect to t of f of u is df du times du dt. Or, said in another notation, the derivative with respect to t of f of g of t is f prime of g of t times g prime of t. When I'm teaching Calc 1 and working with Calc 1 students, I prefer this bottom rendition of the chain rule. But as we go deeper and deeper into mathematics, this really becomes more convenient. For a lot of what we do this semester, this is the way we're actually going to think about the chain rule. So we need a chain rule for vector functions. But like everything else we've done in Chapter 13, the rules for the vector functions simply come from our rules from Calc 1. So let's examine a differentiable vector function r and let f be a differentiable scalar function at t. Okay, so what I want to do is come up with a way of taking the derivative of r of f of t. Well, what I know about r is that it's differentiable at the function f, at whatever value I'm plugging in there. And for convenience, let's give the components of r of t a name. X of ti plus some function y of tj. But one thing we should note is that if r is differentiable at f, then x, y, and z all have to be differentiable at that function f. So another way of thinking about this question is to rewrite it as the derivative of, well, I'm plugging f into r of t, so I can just simply do that in all three components. So I'm really taking the derivative of x of f of ti plus y of f of t j plus z of f of tk. Well, what I have now is the job of taking the derivative of all three scalar functions in the components, and those are just chain rule problems from Calc 1. So this derivative is dx df times df dt. The derivative of the outside function with respect to f, with respect to the inside function, leaving it alone, times df dt in the I component. And I just do that for all three components. Well, all three of these things have a df dt in them, so I can factor that out. And what I'm looking at is then dx df in the I direction plus dy df in the j direction plus dz df in the k direction, all times df dt. And so what I realize that this boils down to is that this is the derivative of that vector function r with respect to f times df dt, or r prime of f of t times df dt. And these look just like chain rules from Calc 1, just applied to vector functions. This is a very common way we're going to see the chain rule this semester, but we can also interpret it this way.